Here we have a pre-calculus problem. Okay, let's go to the question. Is the function f continuous at x equals 2? So there is a function given over here. That is f of x equals to x squared into 4 over x squared into 3x positive 2. So we have to check whether the function f of x is continuous at x equals to 2. Okay, so we have three conditions to check whether a function is continuous at a particular value of x. Okay, first let me explain the condition what we have. Okay, the first condition is, so let me take this problem itself. So we have to verify whether f of x is continuous at x equals to 2. So for that, what I need to do is I have to plug in x equals to 2 into the given function. So when I do so, I'll be getting a f of 2. So the result of f of 2 must be a real value. Okay, so this is the first condition. And the second condition, I have to evaluate the ordinary limit or two-sided limit at x is equal to 2. That is limit x tends to 2 f of x. So I have to evaluate limit x tends to 2 for the given function f of x. So this one also must be a real value. Okay, now, so the third condition is, so the result, the results what we got in step 1 and step 2 must be equal. That's the third condition. That is limit x tends to 2. F of x must be equals to f of 2. So this is the result we get from step 2 and this is the result we get from step 1. So the results we get from step 1 and step 2 must be equal. That's the third condition. So if all the three conditions are satisfied for x is equal to 2 in the given function, then we can say the given function f of x is continuous at x equals to 2. Okay, in case, so I'm just checking the first condition, that is I'm finding the value of f of 2. So for example, if f of 2 becomes undefined, that is I don't get a real value as a result for f of 2. So what should I do? So we don't have to proceed further. So because in this step itself, we can stop because I said clearly all the three conditions have to be satisfied so that we can say the given function is continuous at x equals to 2. Even if the first condition itself is not satisfied, we can say the function is not continuous at x equals to 2. Okay, anyway, so let's verify the first condition. For that, I have to plug in x equals to 2 into the given function. So let me plug in x equals to 2. So wherever we find x on the right side, I have to plug in 2 for x, and I'm getting 2 square negative 4 over 2 square negative 3 times 2 positive 2. So here 4 negative 4 over 4 negative 6 positive 2. So we get 4 negative 4 is 0, and here in denominator 4 positive 2 is 6, 6 into 6 0. Okay, whenever I evaluate a function for a particular value of the variable, so if the denominator becomes the numerator becomes 0 or non-zero, it doesn't matter. Always the denominator matters. So here the denominator becomes 0. So that means whenever the denominator of a fraction is 0, when I evaluate a function, so it's called undefined. So here some people may have a question. So usually when we have 0 over 0, it's called indeterminate form. So when I evaluate limit x tends to f of x, that is when I evaluate limit, if I get 0 over 0, it's called indeterminate form. But here I'm not evaluating a limit, I'm evaluating the value of the function at x equals to 2. So when I evaluate a function for a particular value of x, if I get 0 over 0, it's called undefined. So here I have to consider only the denominator. Since the denominator is 0, the value of the function is undefined at x equals to 2. So the value of f of 2 is not a real value. F of 2 becomes undefined. So the first condition itself is not satisfied for the given function at x equals to 2. So the given function is not continuous. So among the given choices, we find that f of 2 is undefined in option C. That is the first condition is not satisfied. So option C is the correct answer. So that is the function is not continuous at x equals to 2 because f of 2 is undefined. So the correct answer choice for this one is option C.